Okay, in example number 8, we're going to solve the 3 by 3 system using the inverse of a matrix. So the first thing we're going to do is going to write out the equation A times X equals B. Now remember that A represents the coefficients of the variable terms. So we have 5, negative 4, negative 1, 15, negative 11, negative 3, 56, negative 41, and negative 11. And then X represents the variable matrix, which is going to be X, Y, and Z. And then the constant matrix, which is B, is going to be 35, negative 26, and negative 7. So the first thing we want to do in step 2 is we need to find the inverse of matrix A by augmenting with the identity, since we do not have a formula for that. So we have 5, 15, 56, negative 4, negative 11, negative 41, negative 1, negative 3, negative 11. We have 1, 0, 0, 0, 1, 0, 0, 0, 1. So the first thing we want to do is we want to get a 1 in the upper left-hand corner. And before we do that, we can make this negative 1 into a positive 1 by multiplying the entire row by negative 1. So negative 1 times negative 1 is positive 1. Negative 1 times negative 3 is positive 3. Negative 1 times negative 11 is a positive 11. Negative 1 times 0 is 0. Negative 1 times 0 is 0. And negative 1 times positive 1 is negative 1. And now what we can do is we can rearrange row 3 with row 1 so that 1's in the upper left-hand corner. So now row 1 is going to become 1, 3, 11, 0, 0, negative 1. And row 3 now is 5, 15, 56, 1, 0, 0. So now what we can do is then we can go ahead and make the element in the third row, which is 5, become a 0 by multiplying row 1 by negative 5 and adding it to row 3. So negative 5 times row 1 plus row 3 is going to equal row 3. Negative 5 times positive 1 is negative 5, plus 5 gives you 0. Negative 5 times 3 is negative 15, plus 15 is 0. Negative 5 times 11 is negative 55, plus 56 gives you 1. Negative 5 times 0 is 0, plus 1 is just 1. Negative 5 times 0 plus 0 is 0. Negative 5 times negative 1 is positive 5, plus 0 gives you positive 5. So now we have 0, 0, 1 in our third row. Now we want to make this negative 4 0. So we can multiply row 1 by positive 4 and add it to row 2. So 4 times positive 1 is positive 4, plus negative 4 is 0. 4 times 3 is 12, minus 11 is 1. 4 times 11 is 44, minus 41 is 3. 4 times 0 is 0, plus 0 is 0. 4 times 0 is 0, plus 1 is 1. 4 times negative 1 is negative 4, plus 0 is negative 4. So now we have our 1, 0, 0, 1, 0, and 1. So we have a diagonal of 1s, and we have zeros below it. Now, we want to get the identity matrix here, so we have to make sure that this 3, this 11, and this 3 become 0. So one way of doing that is that we can use this 1 in the second row and multiply it by negative 3 and then add it to row 1 to make that a 0. So, negative 3 times 0 plus 1 is 1. Negative 3 times 1 is negative 3 plus 3 is 0. Negative 3 times negative 3 is negative 9, plus 11 is 2. Negative 3 times 0 is 0, plus 0 gives you 0. Negative 3 times positive 1 is negative 3, plus 0 is negative 3. Negative 3 plus negative 4 is positive 12. 12 minus 1 gives you positive 11. So now we have 1, diagonal 1, still zeros here. We have a 0 here. Now we need to make this 2 a 0, and we need to make this 3 a 0. So we can use row 3 to be able to make 3 a 0 by multiplying row 3 by negative 3 and adding it to row 2. So negative 3 times 0 is 0, plus 0 is 0. Negative 3 times 0 is 0, plus 1 is 1. Negative 3 times 1 is negative 3, plus 3 is 0. Negative 3 times 1 is negative 1, plus 0 is negative 3. Negative 3 times 0 is 0, plus 1 is 1. negative 3 times negative 5 times, positive 5 is negative 15, plus negative 4 gives you negative 19. So now the last thing we want to do is make this 2 a 0. So we're going to multiply row 3 by negative 2 and then add it to row 1. So negative 2 times 0 is 0, plus 1 is 1. Negative 2 times 0 is 0, plus 0 is 0. Negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times 1 is negative 2, plus 0 is negative 2. Negative 2 times 0 is 0, plus negative 3 is negative 3. Negative 2 times 5 is negative 10, plus 11 gives you positive 1. So, now that we've accomplished our goal by getting the identity matrix on the left side, we have a diagonal of 1s and 0s everywhere else. Then on our right side becomes our inverse of matrix A. And our inverse is going to be negative 2, negative 3, 1, negative 3, 1, negative 19, 1, 0, and 5. And then what we're going to do is we're going to multiply both sides of the equation by the inverse. So over here on the left side, if we multiply the inverse of matrix A by matrix A, it's going to give us 1. So that means over here is the identity matrix, which is 1 times the variable matrix. On this side, we can go ahead and multiply each row by that column. So we have negative 2 times 35 plus negative 3 times negative 26 plus 1 times negative 7. Then we have negative 3 times positive 35 plus 1 times negative 26 plus negative 19 times negative 7. And we have 1 times 35 plus 0 times negative 26 plus 5 times negative 7. So let's go ahead and multiply it out. We get negative 70 plus 78 minus 7, which gives you a value of 1. We get negative 105 minus 26 plus 133, which gives you 2. And 35 plus 0 minus 35, which gives you 0. So what this tells us is that x is equal to 1, y is equal to 2, and z is equal to 0. So therefore, the ordered triple, which is the solution, is 1, 2, 0.